So we're going to continue our discussion on how to combine rational expressions with different denominators. So as you could see here, obviously these two fractions have different denominators. And this is another example, and the denominators are also different. So we could just have gone ahead and multiplied this, okay, this fraction with this denominator, lift this and multiply this top and bottom with this expression, and do the same with this fraction here. And the same thing with this. But remember, when the denominators are not factored and they are factorable, you have to factor them so you could find your limitations or your constraints. So can you, and after factoring these two expressions here, you will see a slight difference in their factors, which will make a big difference in your simplification. So just pause this video and try to factor the denominators of this and this one too. Okay, so when you factor the denominators of this first set of fractions, you will see you're going to have here a simple trinomial, and this one is also a simple trinomial. And you should have gotten x plus 2 and x plus 1 here, x plus 3 and x minus 1 on the other one. And this other set, you're going to get the denominators as x plus 2 and x plus 1, and x plus 2 and x plus 3. So I just want to emphasize that the simplification of these two are slightly different, because these two denominators do not have a common factor, but these two denominators has a common factor, which is x plus 2 and x plus 2. So go ahead and pause this video again and try to simplify this. It's going to be a slightly long process. So now you already have your practice, and hopefully you have done your homework, so you are able to simplify this. So go ahead and pause and solve this on your own. So we're going to get our least common denominator by multiplying this fraction with this expression and this fraction with this expression. So we're just going to multiply this. So you have to lift this whole denominator, x plus 3 and x minus 1, and this one will also be x plus 3 and x minus 1, and this one will be multiplied by this 2, the whole denominator of your first fraction. So x plus 2, x plus 1 over x plus 2 times x plus 1. So you're going to distribute this. So let's just multiply, continue multiplying. These two will be this, right? So it will be x squared plus 2x minus 3 multiply, and then here negative 2x multiplied by x plus 2 and x plus 1 is, I hope you can do that mentally, x squared plus 3x plus 2 all over. So now they have the least common denominator. They have the same denominator, so we can combine them, x plus 2, x plus 1, x plus 3, x minus 1, and the same here. Okay, so let's go ahead and distribute this. That will be 5x squared plus 10x minus 15. Negative 2x will be distributed there, will be negative 2x to the third negative 6x to the second power, and negative 4x. So now we have to combine like terms. Negative 2x squared stands on its own. There are no other common like terms with negative 2x squared or 2x to the third. Negative 5x squared will combine with negative 6x squared. So that would give you negative x squared. 10x will combine with negative 4x. Will be 6x and negative 15. So that's the sum of your numerators, and your denominator will be the same. So we'll try to see if our numerator is factorable. Maybe we could cancel one of these factors here at the denominator. So since there are 4 terms, we will try grouping. So group the first 2 and try to see their GCF will be negative x squared. So what's left there is 2x, and that will be plus 1. And what's common here will be 3, positive 3. 2x minus 5. So these 2 parentheses are not the same, therefore it is not factorable using grouping. So this is not factorable, so this will be our final answer. We just have to write our limitations. X cannot be equal to negative 2, negative 1, negative 3, and 1.